Hi guys, welcome back to the channel. My name is Jag, and in today's class we are going to cover Chemistry 11, and we're going to move on to how to calculate the molecular formula of a compound. Alright, with that, let's get started. Let's try some of the examples from the textbook I have open in front of me. Okay, and again, I'm going to read the question out loud. Okay, and I'm going to write down what is given in the question. So let's put example here. Okay, and so with that, let's get started here. Okay, so the empirical formula of ribose, which is a sugar, is CH2O. Okay, so just like this. And in a separate experiment using a mass spectrometer, the molar mass of ribose is determined to be 150 grams per mole. Okay, so what they give you here, so I'm going to put 150 grams per mole. Okay, and what's given here, this is the actual molar mass of the compound. Okay, and it's saying what is the molecular formula of ribose. So remember, in the last video what we covered was the empirical formula of a compound, and this is basically the formula that cannot be reduced at all. Okay, whereas the molecular formula, you will see in just a second, is a formula that I can actually reduce. Just like in math, you're kind of like simplifying the formula until you get the empirical formula of the compound. Okay, so what's given here, this is actually the empirical formula. It's CH2O of ribose, which is just a sugar. I'm looking for the molecular formula. So in the first step, what you're going to do, I'm going to find the molar mass of the empirical formula. Okay, so I'm going to put capital M, and I'm just going to write empirical here. Okay, so we don't get confused. Okay, and we're looking at basically this compound right here. Again, I'm using my periodic table, and I'm taking the mass from the periodic table, and it's basically like I'm finding the molar mass, okay, by adding all these masses together. So carbon is 12, okay. Hydrogen is 1.01. I'm just going to round that to 1 so we can keep it simple. 1 times 2, okay. Plus oxygen, and I notice that there's only one atom of oxygen here. Okay, and we're just going to add them all together. I'm getting 30 grams per mole. Okay, does everyone see how to do that? Okay, so this is just the molar mass of the formula, which is the empirical formula. It will be given in the question, and this is the first step. This is all I'm doing here basically. Okay, and then in the second step, okay, what I'm going to do is divide these two molar masses that are given to me. Okay, and it's basically like a value of x. I always write x equals, okay, I'm going to take the actual molar mass. So let's put actual molar mass. Okay, and you can put divided by, okay, the empirical formula molar mass. Okay, so we'll just write empirical mm. Alright, usually you don't have to write, like, this is just a formula so you remember like the steps, how to do it. I don't really need to write out a formula for this. Okay, I just need to remember that I'm going to be dividing the molar masses together. So the one that's given to me in the question is 150 grams per mole, which is the actual molar mass of ribose. And then I'm going to basically divide it, okay, by the molar mass, like the empirical formula molar mass that I found in the question. Okay, so when you divide this, I notice I am getting 5. Okay, and this is the value of x. Okay, in this last step, all you're going to do, so I'm going to write it right here. Okay, what I'm going to do is take this value of x and times it by the empirical formula given in the question. Okay, so look very closely. I'm going to do 5 times, let's put it in brackets, CH2O. And I'm going to put an equal sign here. Oh, let's just make an arrow like this. Okay, so you can see it. So the carbon is basically 1. There's one atom of carbon. Let's put a 1. I'm going to times it by 5. So it becomes C5. Okay. Hydrogen is 2 here. Okay. I'm going to do 2 times 5. And hydrogen becomes 10. Okay. And the oxygen, again, is just 1. And you're doing 1 times 5, so I'm going to put O5. So does everyone see that? I'm going to box this final answer. Okay, so the molecular formula of this compound of ribose, okay, is C5H10 and O5. Does everyone see how to do that? Okay, and you notice we did all of this basically in just like 2 steps here. Okay, So again, in the first step, I'm finding the empirical formula of the compound given. In the second step, I'm writing my value of X, okay? And again, the formula is just the actual molar mass given in the question, divided by the empirical formula that I found in step 1. I divide the two numbers and it gives me a value of X. And in the last step, I'm taking that value of X and I'm multiplying it by the empirical formula that is given in the question, okay? Is everyone all right so far? Okay, with that, let's try one more example, okay, in the textbook. So I'm going to take this off. Okay, and this example is going to be similar, okay, to the one that we just did. And this is just so everyone can get a really good grasp, okay, of how to calculate the molecular formula of a compound. And again, there will be variations to these questions. And we're trying the more simple ones, and everyone can just grasp the concepts first before we try some of the harder questions. Okay, with that, let me pick an example here. So let's do oxalic acid has the empirical formula of CHO2, okay? So this is oxalic acid. And you notice a lot of these compounds basically contain carbon, hydrogen, and oxygen because these elements are very abundant in the atmosphere that they are always forming compounds together, okay? All right, and its molar mass is given to be 90 grams per mole. So I'm going to write that out here. So 90 grams per mole. And again, make sure you are writing out the units every time you calculate the molar mass. Okay, teachers will take off half a mark if they don't see the units here. Okay, and it's saying what is the molecular formula of oxalic acid. Okay, so let's do our two steps here. Let's start with the first step. Okay, I am doing the molar mass of the empirical formula. Okay, after you keep finding the molar mass, okay, of these compounds, for some of these common elements like carbon and oxygen, okay, you'll just know what the actual mass is, okay? Again, if you don't remember, you're looking in the periodic table, and I'm taking the mass from there, okay, and then adding it together. Okay, so here carbon is 12, oxygen is 1, hydrogen is 1, sorry, and oxygen is 16. There are 2 molecules of oxygen here. Okay, so you can see that I am doing 16 times 2, okay? And for hydrogen, you could just like use 1 for hydrogen here. We're getting 45, okay, grams per mole. Okay, just like that. Is everyone good so far? All right, and that's all we're doing here for step 1, okay? So let's do step 2 on this side right here, okay? And in step 2, all you're going to do, again, I'm going to find the value of X, okay? I'm not going to write out the formula here, okay? But it's always going to be the actual molar mass of the compound, okay? So in this case, I have 90 as my actual molar mass, okay? Divided by the molar mass that I found here, which is 45. Okay, and you don't need to write the units in this step, okay? So that's okay. I'm not going to write it down here. This is just going to equal to 2 for the value of X, okay? And you'll notice that the value of X will always be a whole number, okay? I haven't seen any variations of questions where it's a decimal, okay? So this should be a whole number. The teacher won't try to trick you at this point, which is good, okay? And in the last step, I'm going to take my value of X, okay? I'm going to multiply it by the empirical formula given in the question, okay? So my value of X is 2, and I'm going to multiply it by this formula. Let's box it. And put this in brackets, okay? So CHO2. So just like this. I put it in brackets, okay? Just like in math. That way you don't get confused, okay? With the number of atoms here, okay? So if you look closely, carbon has only 1 atom. Let's put 1 beside both of them. Okay, carbon is 1, so I'm going to do 1 times 2, which is equal to 2. If I look at hydrogen, okay, the number of atoms of hydrogen is also 1. I'm going to do 1 times 2. Hydrogen is equal to 2. Okay, I hope everyone is following along here, okay? All we're doing is multiplying the value of X by the number of atoms in the empirical formula. Okay, lastly, oxygen is 2. I'm doing 2 times 2, which is 4. So I have 4 oxygens. Just like this, okay? So this is my final answer actually. So I like to do this actually in 3 steps, okay? That way I know this is the right answer, okay? So we're getting the molecular formula as C2H2 and O4, okay? How I know this is the molecular formula again is basically if I look at all of these atoms for carbon, hydrogen, and oxygen, I notice that they are even numbers, okay? So again, just like in math, I can divide each of these numbers by 2. Okay, when I do that, I'm basically ending up with the empirical formula. Okay, so the molecular formula can always be reduced, whereas the empirical formula is already kind of like the reduced form of the compound. Alright? So again, if there are no questions here, that's going to bring this video to an end. And we covered basically Chemistry 11, how to calculate the molecular formula. Again, there are a lot of different variations of these questions, but make sure you are grasping these concepts. And perhaps in the next couple of videos, we can actually do some questions that are a little bit harder. And that way you can actually excel when you take Chemistry 11. So thank you for watching this video. I hope you learned something. And if you did, please make sure you're clicking on the like button below and subscribe to the channel. And I will see everyone next time. Thanks. Bye.